The Phantom Investor here, and today we're going to be discussing when we're going to be seeing 10 million cases worldwide of the coronavirus. Now, ordinarily, when I didn't have a convenient intercept, I noticed sometimes a doubling or even a tripling, and I would extend that using log functions to find out how much time it would take to get a tenfold increase. And I used log base 3 to the 10, and it would equal that number. And we would count the days from, say, for instance, a 100K increase to a 300K increase. And note that period in days. And then to get a tenfold increase, we would take this period and multiply by that number. Because basically one of this exponent brings you from 1 to 300, then the second two would bring you 300 to 900K, and from 2 to 2.09, that would bring you to the last bit, to 1 million. Sorry if this doesn't make a ton of sense. I'm not trained as a professor. I'm doing the best I can. But in this case, we don't have that. Instead, we're kind of going opposite. We're going from 300,000 to 1 million. So that's like instead of going to here, we're going from like here to there. So we're basically looking at this period of time. Okay? So it's a slightly different track that we have to do. In this case, this is going to be one period plus this little bit. So we'll just say a basic period plus a little bit. We'll signify that by a little triangle. In the mathematics world, they call it delta. And that little bit signifies this little increase from here to there. Well, if the log base 3 to 10 equals this, and we know this, then we know if we just take out this period, that's just like subtracting 1 here. So if you take log base 3 to 10 minus 1, we can equate that with this part of the time frame, not numerically equating. And what I mean by that is that this will spit this number out 1.09, and then we can take this many days, divide by that number, and that will normalize it to give this period. I don't know how to explain that too well to anybody, but basically if you said you had a number like 8.134 divided by 1.03, it's going to give some number, divide by 1. And it's going to display on your calculator as like some decimal form. So whenever you divide something, you're unitizing it. I don't know how to better explain that, but it's basically, if this number represents this period, doing this, dividing by what this will equal, will give you that period. It will normalize it. Sorry, I'm not explaining that very well. I'm not, like I said, I'm not a trained teacher, so excuse me. So we're going to count the days where the amount of cases went from 300,000 to 1 million. And here intercepted on March 21st at 300,000, and again 1 million at April 2nd. So Turn my calculator on. And April 2nd, that's like 31 plus 2, so you can say 33 days minus 21. That is equal to 12. Okay, so up here, this period, we're looking for this period plus this little bit is equal to 12. Okay? So we're going to take 12 and divide it by log base 3 of 10 minus 1, like we talked about. And that's going to take this period and normalize it and give you that period. Okay? So let's see if I can do that. Maybe this will give me a funky number. I don't know. So divide by log 3 10 minus 1 close parentheses, and we get 10.94987147, or you can just say 11 days about per tripling period. Okay? Sorry if that didn't make too much sense. Forgive me. So, yeah, so that gives us 11 days per period to triple. So now we want to multiply by this number to get the tenfold period. So let's see if we can get that to work. Okay, so base 3, 10 equals that times 11. Sorry. So we have 23 days about 23 days per tenfold increase. So here we have April 2nd, day 23 plus 2. That's saying April 25th, 10 million cases, of COVID-19 worldwide. Okay, so that's a prediction. Let's see how we do. Hopefully it gets slowed down, and hopefully it doesn't speed up. You know, here in the early days it went fast, and then China and the Wuhan province locking it down sort of slowed it down, and then sort of took off here in early March again. You know, once the cat gets loose out of the bag. Okay, folks, stay safe. This was the Phantom Investor.